Good morning and welcome to the U.S. Department of the Interior. My name is Tim Fullerton. I'm the Director of New Media here. And we want to welcome you this morning for joining us about this very important chat about the East Coast earthquake that affected many of us earlier this week. We are fortunate enough to have Dr. Mike Blanpied with us today from the U.S. Geological Survey, who serves as the Associate Coordinator of the USGS Earthquake Hazards Program. He will be answering your questions for the next 30 minutes. So if you haven't already submitted a question, you can do so in the chat box below the feed, and we'll get to as many of them as we possibly can. But at first, I want to turn it over to Dr. Blanpied, who will give us a brief overview of what we saw earlier this week.
Well, thanks very much, Tim. This was really an exciting Tuesday in the D.C. area and throughout Virginia. We had a magnitude 5.8 earthquake in central Virginia. It was the biggest one that any of us had experienced on the East Coast, and that the East Coast had experienced in quite some time. The shaking from that earthquake, as is typical for eastern U.S. earthquakes, went very far. People were shaken, detected the earthquake all the way up to Maine, to Florida, Ontario, and west at least as far as Missouri. Very widely felt earthquake, perhaps the most number of people feeling an earthquake in the United States since the country's beginning. We were very fortunate that the earthquake struck in a relatively unpopulated area. It caused some damage from place to place, but no deaths. And that was extremely fortunate. That earthquake, had it landed right underneath an urban area, really could have been quite damaging. And this earthquake really it serves as a warning to us that earthquakes are not just a West Coast problem, they're a national problem. And it's a sort of a wake-up call that well, we know we need to be prepared for hurricanes and winter storms and so forth. Earthquakes are another hazard that face us in the central and eastern U.S., and we can be ready for those as well. And there are some simple steps to prepare, make sure your family, your business, and yourself are prepared to react if an earthquake does strike, and to make sure that you ride it out safely, and that if services are disrupted and so forth, that you're okay in the days afterwards. And we can talk about those things if there are questions on those subjects later on.
Great. Well, let's jump into the first question. This one came in from the live chat a few seconds ago. The question is, how often do earthquakes hit the East Coast?
Well, not nearly as often as in the West Coast, of course. We have the perception that earthquakes are really a West Coast issue. In fact, earthquakes strike every state in the country, but with much more frequency on the western U.S. than in the East, with some exceptions. Earthquakes are really patchy in where they occur. We have a zone in central Virginia called the Central Virginia Seismic Zone that does experience frequent small earthquakes and occasional large ones. Some of you may remember in December of 2003 there was an earthquake of about 4.5 in the same area that caused quite a bit of shaking. We have to look farther back decades or centuries to see the larger earthquakes throughout the eastern U.S. and eastern Canada. There have been earthquakes as large as in the low 7s that have caused in some cases quite a bit of damage, and were they to happen today would cause more damage. So we do get earthquakes from time to time, not with the frequency of Los Angeles or San Francisco or Seattle, but from time to time.
Great. Well, speaking of San Francisco, we have a question from Larry out there, who probably has a lot more experience with earthquakes than some of us who have felt the one on Tuesday. And his question is, are there major fault lines in Virginia, as there are in California, like the San Andreas Fault, or is Virginia on a larger flat tectonic plate with no fault lines?
Well, there certainly are fault lines. The tectonic plate, we're in the middle of the tectonic plate here. The boundaries of that on the west are the San Andreas and the Cascadia subduction zone running up the Pacific Northwest. And on the east, the edge of the tectonic plate actually runs down the middle of the Atlantic Ocean. So we're sitting in the middle, which is a relatively stable part of the tectonic plate. The rocks here are old and cold, but they preserve in them the faults that were part of the processes that led to the formation of the continent hundreds of millions of years ago. So there are lots of faults available to have earthquakes, and there are stresses bearing on those faults, but in very few cases can we identify a particular major fault zone that is likely to have a big earthquake. It's more kind of a smattering of earthquakes on fault zones, and in some cases we don't really even know which fault it was that had the earthquake, and that's the case for Tuesday's magnitude 5.
Great, thank you. We have a question from Rhonda in Colorado asking about the earthquake that happened out there a few days before. And her question was, hours prior to the East Coast earthquake, there was one in southeast Colorado. And her question is, were these two related?
Probably not. We do know that earthquakes can talk to each other. Aftershocks are a manifestation of that. If you have a big earthquake, it causes stresses and other influences on the faults in the immediate vicinity, and that leads to aftershocks. Very large earthquakes can be observed to cause earthquakes to light up quite a distance away. But in terms of a magnitude 5, we really don't think that magnitude 5 or 6 earthquakes can communicate over those sorts of distances. So it's most likely just happenstance that the two of them occurred that close together in time.
Great. We're going to move to a preparedness question because many of us, including all of us in this building, felt the earthquake on Tuesday, but many of us are not used to that experience. And so one question that came in from Rose in Washington, D.C. was, is it safer to stay put in or go in the basement or go outside during an earthquake?
Yeah, well, during an earthquake, you generally have very little time to actually react. And the best thing to do is to be prepared to take the right action immediately. If you're indoors, get underneath a heavy piece of furniture. Drop down, cover your head in case there are falling objects, and hold on. Drop cover and hold on. If you're already outside, then move away from buildings where there might be falling objects coming off the buildings, pieces of brick or whatever that could hurt you. If you're very near a building and you could duck into a doorway, that might be a safe way to do it. What you don't want to do is to rush from inside the building to outside, because in fact one of the least safe places is directly outside the building where things could be falling. If you're in your car, bring the car calmly and safely to a stop. The car is actually a fairly safe place to be unless you run into somebody, so that's fine. And so just take some calm actions to protect yourself, and the biggest hazard really for buildings in this country is falling objects, and so protect your head.
Great. Well, we were talking off camera a moment ago about a lot of people were thinking that doorways were the safest place if you're in a building, but what you're saying is actually get under a desk or get under some heavy furniture is a better idea than standing in a doorway.
That's right. In older generations of construction, when we were building houses of rock, say, there would be a heavy beam that would be part of the integral construction of the building that would make doorways a very safe place to be. In modern construction, doorways are not a particularly safe place, plus you've got the problem of the swinging door. So really it's better to get yourself under furniture if you can, rather than rush to the doorway.
Great, thank you. The next question, we got a lot of questions about hydraulic fracking, and the question that was coming in the most was, do you see any connection between earthquakes and the process of fracking for natural gas extraction?
Well, we know that the fracking process can cause, that's where we're inducing fractures into rock within a well in order to increase the ability to extract things from the rock. That process can cause very small earthquakes, but it's not, the fracking process doesn't really, we don't think, induce large earthquakes. The thing that can induce larger earthquakes is the high pressure fluid injection, waste fluid injection that's done in some places. However, as far as we're aware, there's not really the mining or the fluid injection processes going on in Virginia that would have connected this earthquake with anything like that. And just to be clear, that the connection between fracking and fluid injection and earthquakes is an area of active research, and really we're only starting to learn about how those things are connected.
Great. Thank you. Well, we have we're going to move to another question from Linda in Tennessee, which is a four-part question, so we'll try to get through this. One was, what fault caused this quake? Do we know approximately when this fault was last activated? And actually, we're going to go to the third part, but if so, what time frame estimate is available for more activity on this fault?
Yeah, the Central Virginia seismic zone is characterized by sort of a diffuse area of seismicity, of earthquakes. And those earthquakes don't appear to line up along a particular line that we would identify as an active fault. It's more that there's high stresses in the rocks, and we can talk about why if you're interested, but that cause earthquakes, probably on numerous faults at various places at depth. So the 5.8 earthquake did not come to the surface and cause rupture at the surface, such as on the San Andreas Fault when there's a big earthquake. It was buried. We don't really know which faults are there, and we may never know which fault this earthquake happened on. What we can do, given that absence of knowledge, is to look more generally at the rate of earthquakes that occur. And we know that earthquakes of magnitude 4 happen on the sort of several decades scale. Magnitude 5s more rarely. We've had 2 in Virginia in 100 years or a little more. And then we can use that information about the general frequency of earthquakes to then say what the hazard is, that the hazard from shaking, and it's that kind of information about how likely it is that the ground's going to shake regardless of where the earthquakes actually came from. It's that information about shaking that can give us the building code provisions that can allow us to make safe structures. And really that's the key. Earthquakes can come and go, and if we have nice safe structures and we're ready to ride out the earthquakes and ready to go with, if the electricity goes out, we're ready to deal with that, then earthquakes really aren't a problem.
Great, thanks. Well, this is probably a good point to just welcome the people who are joining us now. If you've missed the first 10 or 12 minutes of this chat, it will be available on DOI.gov next week. And also, if you're looking for more earthquake information, the USGS has a great section of their website at earthquake.usgs.gov. There's a lot of information there, so if you get a chance, you should definitely check that out.
One of the interesting features on the website, for those of you who felt the earthquake, is a feature called Did You Feel It? If you go to the USGS website or earthquake.usgs.gov, for any particular earthquake, if it's a large earthquake there, you can actually fill out a short form that contributes your experience from the earthquake. And that helps us build a map that shows the distribution of shaking. And there's a beautiful map for this Virginia earthquake because about 135,000 people have contributed all over the eastern U.S. and southern Canada. And so it very beautifully shows the distribution of shaking from place to place. And that's of scientific use as well, so we appreciate your contributions.
That's great. The next question as we move on is from Adnan, who wanted to ask, what is the maximum intensity of an earthquake that could hit the East Coast?
Well, we can't really say what the maximum is. We can look at experience over the last few hundred years. And the biggest earthquakes that have struck have been in the low 7s. There was an earthquake off the Grand Banks south of Newfoundland back in 1929 that was estimated to be about a magnitude 7.2. There was an earthquake in Charleston, South Carolina in 1886 that did quite a bit of damage. That was somewhere in the low 7s, 7 to 7.2, 7.3. And so we know that earthquakes of that size are capable of happening. And so we build that into our understanding about the likelihood of shaking. And another place in the central U.S. that we know is capable of large earthquakes is the New Madrid seismic zone that sort of runs between Missouri, Tennessee, Kentucky, in that area, where back in 1811, 1812, there were a series of very large earthquakes that we estimate to have been at least magnitude 7. And the largest of those, which was probably in the mid-7s, 7.3, 7.5, something like that, that again caused very widespread, even heavier shaking than we experienced on Tuesday, and actually caused quite a bit of shaking all the way to the East Coast in the Washington area.
Great. All right. Well, we're going to move to another question that's specific to D.C. You
Okay.
can definitely see there's a lot of interest on the East Coast about this.
Sure.
Linda in the district is asking, did last year's D.C. earthquake, which was around a magnitude 3.4 on July 16th, and coupled with this earthquake that was a 5.8, does that say anything about an earthquake happening in summer of 2012?
No, not particularly. We know that the actual greater D.C. area itself is relatively quiet seismically. That magnitude 3.5 or so earthquake was the largest one that had been recorded in this area. And it caused shaking over a fairly widespread part of the D.C. area, and a lot of people felt it. But that's at a fair distance from the central Virginia seismic zone, which is a much more active area of earthquakes. And there's probably not really much communication between the two. Mm-hmm. And the fact that we occasionally have earthquakes here and we a little more occasionally have earthquakes there doesn't indicate that we're on the ramp to anything in particular coming up in the next summer or even in the next longer period of time.
Great, thanks. Another question, this is from Sally, again, D.C. related. Is the D.C. metro area close to the Appalachian Fault? And if so, why has there been a long gap between seismic movements? And should the Appalachian region be expecting more activity in the near future?
Well, there are parts of the Appalachians that are quite seismically active. Southwestern Virginia, there's actually a zone of eastern Tennessee that has quite active, the Eastern Tennessee seismic zone. And again, these are places that have large amounts of stress left over from the plate tectonic process. There's additional stresses that have actually been added due to the process of glaciers advancing down over the northern part of the United States and then retreating. That weight of that ice load has actually probably caused amounts of stress that are being relaxed and causing changes in the stressing on faults and so forth. That's again an area where we're trying to get a better understanding of how those stresses work. So yeah, the best thing to do is really to look at the history of earthquakes. And again, the USGS is a source of maps like that. For every state or for every region, we have maps showing the historic seismicity and also our understanding about the shaking hazard related to potential future earthquakes. So people can take a look at that.
Great, thanks. The next question is from Jake, who asked it on the chat here, and his question is, how come this quake was felt all the way in Chicago, but the one in Colorado earlier in the week wasn't felt quite as far?
Yeah, that's a great question. Yeah, central and eastern U.S. earthquakes really are interesting beasts. Once you get to the Rockies west, the continent is younger. There's more active processes going on related to the building of the Rockies, and then of course the very active plate tectonics farther west. Those rocks are younger and warmer and more chewed up than the rocks in the eastern U.S. If you have an earthquake in the east, the rocks are old and cold, and seismic energy, the seismic waves caused by that earthquake travel very far through those old cold rocks, and so they can spread all over the eastern U.S. If you have a magnitude 5.8 in Nevada or California or western Colorado, the felt area will be much more compact. So the difference between this and the Colorado earthquake, one is the Colorado earthquake was much smaller, and it was in a younger geology, so it just isn't felt as far.
Great, thank you. The next question is coming in from the chat as well, and actually we've had a few people ask this, and they're asking about are there any known faults that go through the Manhattan region?
Yeah, New York has a hazard that the whole New England area does. Again, there are older fault zones that are remnant there, and occasionally there are earthquakes. There have been earthquakes large enough to cause some pretty heavy shaking in the New York area. Back in 1944, there was a magnitude high fives, magnitude 5.8 earthquake that shook near the New York region. Particular faults have been mapped, and there are probably other faults that we don't know about. And so we do have a concern for our eastern cities that have an older set of buildings that are not built for modern seismic safety. Even, as we said, a magnitude 5 earthquake that occurs in rural Virginia, we got to pass on that. If a magnitude 5-point earthquake occurred near Manhattan, near Boston, we could have a problem.
Okay, great. Thanks for answering that. We're going to move to another preparedness question, and This is a question from Tom, who is out in Minnesota. And he's saying, I'm very concerned by the lack of public understanding of what to do when an earthquake hits. Not so much in areas where preparation, training, and public understanding exists, but in areas like D.C. or even in areas such as rural Minnesota, where Tom is from. The image on TV suggests the opposite of drop cover and hold on. What can we do to increase public understanding on what to do in the event of an earthquake?
Well, I think one thing to do is just to use the earthquakes that do occur as reminders to get prepared. There are sources of information from USGS. If you go to earthquake.usgs.gov/prepare, there's information there and links to others. The FEMA website has a lot of good information. The Red Cross website has a lot of good information. In preparing in advance for earthquakes, you actually take many of the same steps as you do for preparing for other hazards. Hurricanes, ice storms, electrical outages, tornadoes if they're in your area, and so forth. It's having a plan and having supplies. Having a set of supplies on hand where you've got food, water, maybe a camp stove. Some people have a generator. Medicines if you have prescription medicines, kids' toys, whatever it is going to take so that your family or your business place can be comfortable and just sort of ride it out in the days after, if a hurricane comes through or an earthquake knocks out the electrical grid or whatever. And then the other thing is to have a plan. You know, the worst feeling is to have an earthquake knock out the communication system and you don't know who's supposed to go to the school and pick up the kids or where you're supposed to meet. So having an idea ahead of time, just, okay, you're going to go there, I'm going to go there, we're going to call Aunt Susie, just have that kind of worked out so that you know what you're going to do. And for businesses, have a plan for what's the response of the employees going to be, how are you going to communicate with the workforce, should they come to the office, should they not, and so forth. Having that all worked out in advance will not only make it a more comfortable situation, but it'll also provide a lot more comfort to people at a time when things are very confusing.
And I think I would just add to that, if you have further questions that are more specific that you'd like asked about preparedness, you can follow the USGS at USGS on Twitter. You can also like them on Facebook, and we try to answer as many of those questions on there. So if you have any questions or have friends or family that have questions that they'd like to have asked, please follow those two social networks, and we will do our best to answer as many of them as possible.
And we can post some on the Facebook page. We can post some links, and also on that /prepare page at USGS.
Great.
There are some links to some good information.
Great. Well, we've got time probably for a couple more questions, so if you've got a really burning question you'd like to ask Mike, please post it now, because we're going to probably stop at 11:30. So we've heard that President Obama is going to be speaking on Hurricane Irene. We see that there's some questions coming in here. So if you're interested in hearing the President speak, go to whitehouse.gov/live, and you'll be able to watch it there at 11:30. But until then, we'll answer as many questions as we possibly can. So the next one comes from Tony from the chat, and he was asking, he heard that this earthquake was on a reverse fault line. And he wanted an explanation of what that was, or if that is even something that exists.
Well, it does exist, and it's more of a scientific interest, but there's basically three ways that faults exist in the ground and that earthquakes occur on them. If my hands are the two sides of the fault, if the fault goes more or less up and down and the sliding is sideways, we call that a strike-slip fault. The San Andreas has strike-slip earthquakes. That's the very familiar example. If the fault is tipped over and one side goes up, so you're pressing the fault together and one goes up over the other, that's called a reverse fault or a reverse faulting earthquake. And that's what happened in Virginia. And that's typical. That we know that there's east-west compression across most of the United States due to the plate tectonic forces. And so faults that are inclined like that will tend to slip in this manner. The other third case is where you've got a pulling apart motion, and then again that inclined fault will slide this way, and for some reason geologists have called that a normal fault. We don't know why they're normal, more normal than the other kinds, but those are normal.
Great. All right. We're going to move to a question from Zach in Virginia, and he's asking, how long will the aftershocks continue in Virginia?
Good question. Almost every large earthquake causes aftershocks, and aftershocks are a manifestation of the stresses that have changed on the faults around. And those aftershocks are generally concentrated in the general area, though you can have some at larger distances. What we know about aftershocks is that their rate falls off in a very kind of predictable way with time. We can't predict the time and location and magnitude of any particular aftershock, nor can we of any earthquake. However, we can say that the likelihood of aftershocks is the highest at the beginning and then falls off with time. Now, aftershock sequences can go on for weeks, months, or even years, and those aftershocks can be large. We may still have more aftershocks of a magnitude 4 size. We may have a magnitude 5 aftershock. It's hard to say. The likelihood of that falls off with time. But the key thing is just to be aware. As the earthquake reminded us that earthquakes are an eastern feature, the earthquake reminds us that we may be feeling aftershocks. And so again, just be prepared. If you feel the shaking, protect yourself, ride it out, and then move on.
Great. All right. The next question has come from Heather, and she is asking, are earthquakes on the East Coast related to continental drift, and when it drifts, causing old fault lines to reactivate?
Yeah, in a general sense, that's right. Continental drift is now generally referred to as plate tectonics. The idea that the Earth's surface is divided into large plates that move relative to each other. Now, as I said, we're in the middle of a tectonic plate here, but we have the forces that are acting around the edges from the other tectonic plates. And to some extent, those forces are keeping compression on the faults in the interior of the plate and leading to earthquakes.
Great. We've obviously got a lot of interest on Hurricane Irene, and TJ in Virginia is asking, is there any relation of the earthquake to the hurricane?
Only in that they are both hazards for which we need to be aware, but there's really no connection between atmospheric phenomenon and hazards and earthquakes under the ground.
Great. And we have a question from Sal Marie here on the chat. Is there any published research that you can recommend for people to read to better understand seismic activity?
Well, there's just lots and lots of activity and material to read. One place to start, there are many places you could start. Just start with web searches or search in the library, but one place to start is earthquake.usgs.gov. We have a tab there about learning, and so you go there and there's lots of information and links to sources, questions and answers, FAQs and so forth. I encourage you to start there. If you do have particular questions you're not able to find the answers, post the questions and we'll try to get those answers to you.
Okay. Well, we have time for one final question.
Okay.
We want to thank everyone for joining us. But the final one, and this one came in from Kathy on Facebook. She wants to know what makes that sound she heard during the earthquake.
Yeah, earthquakes do make sound, and that's one of the characteristics things is, now if you're in a building, you may hear creaking, groaning, squeaking, things like that, rumbling. Those are generally due to the building itself. Buildings groan and creak because all these little parts are sliding around, things may be moving. So usually what people hear is building sounds. However, people have heard earthquake sounds outside, and that seems to have to do with the groaning of the ground. It's just, you're shaking the ground very hard and parts of it are moving around, so there actually are earthquake sounds just due to the motion of the ground.
Great. All right, well, that's all the time we have for today. I want to thank Dr. Blanpied for joining us and answering all of your questions, really, really good questions. If there are more that you would like to have answered, you can go to the USGS Facebook page, where you can follow USGS on Twitter @USGS, and they'll answer as many of them as possible. And as we've mentioned a few times, you can go to earthquake.usgs.gov. And if you're joining us late, the full video of this will be available on DOI.gov early next week. And we just want to remind you that in the next few minutes, President Obama will be talking about Hurricane Irene at whitehouse.gov/live. So again, thank you very much for joining us, and we look forward to talking with you soon.